Hello and welcome to the course on Ubiquitous Computing. Today we'll be starting with the fifth unit, that's Ubiquitous Computing Privacy. Means majorly we are talking about privacy only of a ubiquitous system or Ubicomp. The point with which we'll be starting now is protecting RFID tags. That's a case study. Many times we discussed about RFID tags, and many times I have given the example of RFID tags that are attached to the vehicles nowadays. The government of India has a project of collecting the tolls based upon that RFID tags or the smart cards attached to the cars. RFID tags represent probably the most prominent Ubicom technology, at least when it comes to the privacy issues. Their increasing use, especially on consumer products, in showcase supermarkets, as implants for entering in clubs, and as a security features of electronic passports, have promoted widespread public concern over the RFID privacy issues. The privacy challenges of RFID tags are fourfold, or that is based upon these four components. These four components are automation, identification, integration, and authentication. We will look into each one by one. The first one is automation. Reading an RFID tag typically does not require a help of a person carrying the tag, nor any manual intervention on behalf of reader. Thus, a simple reader gate can easily scan large numbers of tags, making the data acquisition much easier. Means you might have traveled through national highways where the toll plazas are available. The toll plazas are toll plaza gate. When we reach or when our car reaches there, so automatically it identifies on based upon identified tag, it withdraws the amount from our account, the toll amount it withdraws, and that process happens automatically. No human intervention is required. Unfortunately, in our Indian system, they are making the intervention like your tag is not working and something like that. Means definitely it is a breaching of that. But forget about it. Automation is of that kind. Identification is the ability to identify the individual atoms instead of only a whole classes of atoms significantly improves the ability to identify an individual. Next one is the integration. Not only the act of reading a tag can completely hidden from a tag carrier, but also the fact that the tag is present in a particular product will be hard to ascertain for individual without a special detection equipment. And last one is the authentication. The above points become especially critical given the increasing amount of sensitive information. For example, a health information, payment details, or biometric data that are stored on a linked to the tags used in the authentication system. Suppose whatever the critical information that is stored on the card, that is stored on the tag, and if that reader is collecting that information too, means definitely it is breaching the law of authentication, it's breaching the law of privacy, individual privacy. These four attributes of RFID applications threaten two classes of individual privacy, the data privacy and a location privacy. The location privacy of a person is threatened if a tag ID that is associated with that person is spotted at a particular reader location. For example, by knowing that person's car has passed a certain toll station, means identifying a name of that person and disclosing that information, means somebody's car is passed from this toll station. Means definitely this is breaching a law, or this is the threat. Why this is threat? Let's say I'm moving nationalized road, and I have passed some, let's say some toll plaza, and I don't know, somebody is chasing me. And if that individual who is chasing me gets the information of my car that at this time the person is passed, a person's car is passed from this toll plaza, so definitely that information is very much meaningful to the chaser who is chasing, and that should not happen. So that's meaning of this point. The IDs do not need to be unique. Certain combinations of non-unique tags might still form a unique collections of items that can be used to identify an individual. Once tags carry more than just an identifier but also a person's name or account number, data privacy may be violated. This happens if unauthorized readers eavesdrop on legitimate transactions, or if a readers trick a tag into disclosing its personal data. These types of the attacks are typically called scheming. A special case of data privacy are product IDs that disclose details of the belongings of a person. Belonging of a person means account number or a bank name or whatever it may be. There are three principles, means of violating the individual data and or location privacy: clandestine scanning, eavesdropping, and data leakage. The first one is clandestine scanning. The tag data is scanned without the tag carrier's consent. This might disclose personal information either indirectly, for example by revealing a concept of bags that one cannot see through otherwise, or directly, for example by revealing a personal data such as name of the user or the date that a particular item was bought. If the several clandestine scans are fooled, the clandestine tracking can reveal the data subjects movements along a tag reading infrastructure. That is what that belongs to the location privacy. Eavesdropping: instead of reading out a tag directly, one can also eavesdrop on the reader to tag channel and receive the IDs of the tags being read due to the used anti-collision protocol. And the last one is a data leakage. Independent of the actual RFID technology is the threat of having applications read out more information from a tag than necessary, or storing more information than needed. This, of course, is the threat common to all the data gathering applications, although the envisaged ubiquity of RFID based transactions renders it highly relevant in this context. The next point which can be used or which is majorly used with the Ubicom data privacy, and that is called as hashing. Means basically we want to protect the information. Whatever data we collect, the data must be in a protected mode. So hashing is a technique, can be used or can be coupled with a ubiquitous system. So this is an example of ID based hash log, generating the hash log. Means whatever information we are collecting, that's a product ID, serial number, name of the product, and blah 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 blah. This much information that we are collecting, we have some hashing function, and based upon this hashing function we'll be generating a hash code or we'll be generating a hashtag. Getting me? So this is very simple function. H is the hash key generated. Hash is the function which is applied on different components which we read earlier, means product ID, serial number, name of the product, so on and so forth. And the combined hash key that we are generating or combined result of it is a complete hash generated out of this. So this is the end of our 5th unit. We'll stop here. Thank you for watching the video.